Okay, so the function in question 2 here is given numerically, and we're asked to find the following outputs. So for f of 4, this would mean you would find the value for the function when x equals 4, and we can see that would be this column in the table, and so the output value is 1.5 at x equals 2 for part B. Very similar. That would be the second column, and so f of 2 is 3.7, and f of 8 would be this column for x equals 8, and so this would be 1.5. Now, we need to find all input values for which the output from the function at that value is 1.5. So what we're looking for are the columns in the table where the second row has a value of 1.5. And so that would be the first column, right, the third one, and then that one. And these x values are 0, 4, and 8. So that would be your answer. Next part, we're asked for input values for which the output is now 3.7. So looking at the second row, 3.7 is only there. And so this would be at x equals 2. Okay. For question 5, let's look at that one next. Here we're given another numerically given function, and we're asked to find the missing value. So your first step here should be to find a formula for the function, so for h of t. And we can do that first by noting that your input values for t are always going up by 1. So the difference from -2 to -1, you add 1, -1 to 0, you add 1, and so on. And your corresponding output values decrease by 2. So 4 to 2, 2 to 0, you subtract 2, and that would continue all the way down. Now, if we expect that pattern to continue, this would mean that the next value, you would do -8 minus 2, because that's the pattern we observed, and that would be minus 10. So this would be that value, and then this one would be minus 10 minus 2, so -12. So these would be your two missing values, and if you always have an increase in +1, for every increase in 1 in the input, your output values drop by 2. So this means that the formula for h of t would be -2 times t. And you can check the points that are there if you want.